Okay, first thing, we will get the augmented matrix going, and that looks like this: 1, 1, 1, 0, 2, negative 1, 3, 1, 1, 4, 0, negative 1. And we will start to do things to it. Once again, the first thing we do is we want a 1 in the top left, and we've got a 1 in the top left, so we don't have to do anything with that. Then next, we want to get ourselves zeros here. So that's what I shall do first. Top row's already got a 1 in the top left. Now, row 2 is going to take away 2 lots of row 1, and row 3 is going to take away 1 lot of row 1, and that should give me my zeros. Okay, so row 2, take away 2, that'll give me 0 there. Minus 1, take away 2 is minus 3. 3, take away 2 is 1, and 1, take away that gives me 1. Row 3 minus row 1, that gives me 0 there, that gives me 3 there. 0 take away 1 gives me negative 1 there, and negative 1 take away 0 gives me negative 1. And I have that situation. Then, something somewhat unusual will happen, but it's a little bit awkward. What I would like to get myself a 1 there. I can divide by negative 3, but then I'm going to get negative a third next to it and negative a third there. I might just leave that as a negative 3 for now. I'm going to first of all get myself a 0 there. I'll leave the top row. I'm going to leave the bottom row for the time being. I'm going to do row 3 plus row 2. Give me 0. That'll give me my 0 there. 0, 0. But now I've got a whole row of zeros along the bottom. And what on earth does that mean? Here we go. If you get 4 zeros, then there are infinite solutions, infinite number of solutions. If we were thinking about this in terms of 3D space, we would say that the planes meet along a line. Now I'm going to find the equation of that line that they meet along, but there are an infinite number of solutions. So this time, the first time we did this, we met along a point. Second time here, when you get this row of zeros along the bottom, that means that the planes meet along a line. And we will just, I'll just try and make this a little bit simpler. I can make it a little bit simpler, but not particularly. How about if I do, yeah, there's not much I can do with that. I might just leave it looking like it is. Perhaps do row 2, row 1. I'm going to make it a little bit simpler. This won't be much simpler, but anyway, here we go. First of all, I'll do this. I'm going to leave a bottom row full of zeros. Nothing much to do with that. I'm going to take the first row, and I'm going to add, stop that, row 1, add row 2 divided by 3. I'm going to have to bring some thirds in because otherwise I'm not going to be able to get rid of that minus 3 business. So if I do row 1, which is 1, and add 1/3 of negative 3, that'll be negative 1, that'll give me my 0 up in this space here, which is what I'm trying to do. So here we go. Let's see what I get. I'm going to get 1 there. Nothing changed about that. I'm going to now get a 0 here, which is what I was after. But I'm also going to have to do 1 plus 1/3 of 1, and that's, I'll do that as that's 4/3. Over here, that's just 1 plus 1/3 is 4/3. That's what I did to get that. And then the last one, I'm going to get 0 plus 1/3, so I'm going to get 1/3 there. I'll leave the second row with my 1s. And I'm going to stop there. Now, here we go. I'm going to bring in, we have that Z is just Z. We don't know anything about it. It could be any number at all. So it seems silly to write Z equals Z, and I'll show you why. I'm going to change that in a minute. But for now, I've just got my Z equals Z. From my top row, I've got X plus 4/3 of Z equals 1/3. That's what my top row says. And my second row says that minus 3y plus Z equals 1. That's what my second row says. But Z can be anything, and because I've got my rows in my Z column, it means that my zeros in my Z column, I don't know anything about that. First, from this one, I can say that X equals 1/3 minus 4/3 Z, or X equals 1 minus 4Z over 3. From this second one, I get that minus 3y equals 1 minus Z, y equals 1 minus Z over minus 3, which is equal to Z minus 1 over 3. The line is, I'm going to put in here my X, Y and Z. This is my line, and it is 1 minus 4Z over 3, Z minus 1 over 3, and Z can be anything. And then to work out points along that line, if you wanted to, you just try, Z could be anything. Z could be 0, 1, 2, 3, 4, 5, and you get lots and lots of points, and they would all be in a straight line. This is not the standard form. This is correct, but usually we bring in a new variable. Let Z equal t, and then the line, and the equation of the line is 1 minus 4t over 3, t minus 1 over 3, and t. So this is called the parametric form. You could have done it with Z's like I did originally. You didn't have to bring in a new variable, but very commonly people do bring in a new variable. T is the most usual one, and represent it that way instead of just using your Z's. Now, the key to this one is these zeros along the bottom. Sometimes when you do this Gauss Jordan thing, you'll get zeros along the bottom, and that means that your planes have met along a line. Then you have to find the equation of that line. It will have some sort of parametric form. You can put all lines into a parametric form. You can either skip that Z business and go straight to the T's if you want, but I just did that to show you, I wasn't really making it up. Z can be anything, so I just left everything in terms of Z. But usually people turn it all into a new variable T. And that is that there.